Welcome to myprojectbazaar.com. Now we are going to discuss about the project breast cancer detection based on deep learning technique. Now we are going to discuss about the abstract of the process. Breast cancer detection and classification is very hard in nowadays. In fact, tumor is a complex process during which a mammogram images undergoes the various transformations. In addition with that, different images areas are characterized by different tissue types with exhibit the highly variable appearances. Our main contribution in this process is to the image classification, tumor prediction and improvise in performance. Hence in this process we are going to do the image classification whether the input image is having the tumorous regions or not. If it is a tumorous region, it will indicate this is the tumor image. If it is a non-tumor image, it will indicate as a normal image. Our approach is tested in the publicly available dataset only. So the images is obviously collected from the other publicly available datasets. Hence the performance of the process is evaluated by means of the performance parameters like accuracy, sensitivity and specificity. By these three parameters we can justify our process is efficient or not. Now we are going to discuss about the overall flow diagram of the process. This is the overall working flow of this process. At first, the stage of the project is the modules. This is the modules like input image, pre-processing, feature extraction, classification and finally performance analysis. So first stage, in this first stage, input image. The input image is taken from the dataset. The dataset consists of both the tumor image and then the normal image of mammogram image. After getting the image from the dataset, we just move to the next step of the project, that is the pre-processing. In this pre-processing, we have carried out the two stages. First stage is the image resize, then the second stage is the grayscale conversion. By to these things we are improvising the quality of the image. First of all, the input image resize. So the image resize, we are going to resize the image into an aspect size of 256 cross 256, which means the number of row will be the 256, number of column will be the 256. After resizing the image, we are just move on to the grayscale conversion. If the input image is an RGB channels like red, green, blue, it will be converted into a grayscale form. After the conversion of the grayscale format, we are just move to the third step of the project, that is the feature extraction. In this feature extraction, we have two kinds of features. One is the HOG features, then the another one is the CNN features. Why we are choosing these two features in the sense, we have to extract the color-based features based on the HOG features, then the texture-based features based on the CNN, that is the convolutional neural network. By combining these two features, we are generating the test feature. After generating the test feature, we just move on to the classification stage. In this classification step, we have to classify the category as whether it is an normal or abnormal. If it is a tumor region, means the image is considered as an abnormal image. If it is not having any tumor region, means it is considered as an normal image. So we have to classify these things in this classification step. After that, we just move on to the final stage of the project, that is the performance analysis. In this performance analysis, we have to carry out the performance parameters like accuracy, sensitivity and specificity. In other terms, it will be the precision and recall. So this is the overall working flow. Now we are going to discuss about the initial running procedure of the process. First of all, open the Python, the Spider version 3.7 Anaconda 3. So this is the version we are done and that. So first of all, open the Spider. After that, you have to change the current directory like this. If you want to execute the file, just open the main file.py. Then after opening this file, you just go to the run button and select the run. Now the tkinter will be open. In that tkinter, you have to select the image from that dataset. After the selection of the image, the corresponding image will be processed one by one in the console. This is the original image we are selecting from the dataset. After the selection of the image from the dataset, it will convert it into one grayscale format. If the image is having the RGB channels, then it will convert into one grayscale form, or else the image will remains the same. After converting the image into a grayscale format, we have to extract the features from the image. First, in the flow diagram, we have discussed the two kinds of feature. One is the HOG and the second one is the CNN. This is the image for the HOG features. After extracting the HOG features, the extracted feature values is displayed like this. This is the features we are extracted from the HOG. After the extraction of HOG, we just move on to the second stage of the feature extraction, that is the CNN method. So convolutional neural network. This is the layers we are assigned for the CNN. So after extracting the CNN features, we just move on to the classification step. In this classification step, we have to find out whether the input image is affected by the any diseases or not. If it is affected by the diseases like a tumor, means it have to detect the stages of the disease, whether it is the mild stage, moderate stage, or else the severe stage. In this image we have given as an input, we have an affected image, but it is in the mild stage. So the classification, that is the predicted results, will be shown like this. After estimating the classifications, we just move on to the performance estimation. In the performance estimation, the first stage of the performance is to deduct the confusion matrix like this. This is the confusion matrix. It will segregate the performance like true positive, true negative, false positive, false negative, and finally based on this one we have to generate the formula for accuracy, precision and recall. So this is the value of accuracy, precision and recall for this particular classification. Then the confusion matrix C1 is shown like this. Finally, the performance graph between the existing and proposed of accuracy, precision and recall will be displayed in this bar chart format. Thanks for watching this video.